Hello, this video is about adding one observation to a sample and then recalculating the sample mean and the variance. Now the ultimate reason I'm doing this video is for the next video, where in what I think is a unique way, we're going to prove that the sample mean and the sample variance are independent when the data are normally distributed. Okay, but in this video we're going to assume that we know n, the sample mean of sample n, the sample variance of sample n. However, we don't know the actual observations. We want to add one observation, call it x of n plus 1, and then calculate the mean and the sample variance for our new sample based on n plus 1 observations. And to me, this is kind of a fun little trivia note that may turn up useful. So the mean it's a little more straightforward. We know it's just add up the data, divide by n plus 1. But we can separate this sum from 1 to n and the last observation. And then if we multiply and divide by n, that's multiplying by 1, it doesn't change it, and we get this. Well, and then we're finished. We know n, and we know the sample mean, and we know the next observation. So this calculation is the sample mean of a sample based on n plus 1 observations. Now let's look at the sample variance. Sample variance is defined like this. It's the sum from 1 to n plus 1, xi minus the mean of x plus 1 squared. Now, what we're going to do here, instead of summing from 1 to n plus 1, we're going to sum from 1 to n and take that n plus 1 value, or that, quadratic, to the side. So this is it. That's the n plus 1th term in this. And then we have 1 to n. But then we add 0. We add and subtract x bar n, which doesn't change this. And so this equals this. Now we're going to expand this quadratic. Think of these together. So we take this times itself, this times this, and then this times that. We get 2 of them, and then this term times itself, and then this term just comes down. Next, we are going to, this right here is like the sample variance for a sample of size n. So this can be written like this, n minus 1 times that sample variance. And then here we just multiply this together. So we get xi times the mean, times the sum, and which is this term, xi n plus 1, and then this term, and then that term. Right? So then we multiply this out. We get it times itself, but there's no index, and so there's n of them. And that's this times this times that, and then there's no index, so there's n, minus 2n of them. This times itself. Then we expand this, and then there's 2 of those, and then we get squared, n plus 1 squared. Then we note that these 4 terms here all cancel. Okay, so if we look at these 2 terms, okay, so if we divide by n and multiply by n, then that's xn bar squared, which is what this is. There's 2n of them, minus 2n, they cancel. And the same argument goes for these 2 terms. They cancel. Multiply and divide by n, then it's this. So you get minus 2n of them and plus 2n of them, and they cancel. So let's carry these down. So that goes here, there, all the terms. So now what we're going to do is we're going to replace the n plus 1 bars. Okay, so up here we have a term for x n plus 1 bar. So we're going to replace it here. Now these, the x n plus 1 bar squared, we're going to combine those, factor it out, so it's going to be x n plus 1 bar squared times n plus 1 when you factor that out. But then otherwise, we're going to put it in here and here. And unfortunately, I got to flip the page. So that's what we do. So we just plugged in, so this is x n plus 1 bar. And then remember, I factored it out and we ended up with n plus 1, and that's this. So now, what we want to do is multiply this through, okay? So this comes down, this is down, multiply this in, or you know, you can think of factoring out the n plus 1, and then this times that, this times that. And then over here we get n plus 1 squared, but one of those cancels with this, and if you factor it out, you go there. So then that squared, this times this, you get that squared. This comes down, this times this, that times that, and you get those two terms. Now, these two cancel, right? If that n plus 1 comes in, you get 2n over n plus 1 this, and then minus 2n over n plus 1 that. So those go away. Now, what we're going to do next is, of these terms here, not this, of what's left, we're going to factor out an n over n plus 1. So that's what this is. So this comes down, and we're factoring out n over n plus 1. So then this, since there's no n plus 1, then we have to multiply it by n plus 1. Here, n plus 1 goes, one of the n's goes. Here we're left with the 2. And then n plus 1 and one of the n's goes, we're left with this. That was canceled in the previous, we get this. This term is here. And since there's no n or n plus 1, then we have to, you know, reverse it here. That's canceled with that. That is this. Now, next, we get some cancelizations. So notice this is minus 2n xn bar squared. This is n xn bar squared. So one of those cancels, and we're left with a negative n. But when we multiply that piece in, we get an n times x bar squared. So that cancels with the remaining piece. So then what's left over is we get this. We get n over n plus 1. We get that 1 left right here. That comes down. That's canceled. And then we get this. No. Oh, when you combine this term, and this term, it just adds to xn plus 1 squared. Now, this piece here is a squared. Right? If you square this, you get this back. Well, then now actually we're finished, right? So remember, this is x n plus 1 squared is equal to this. So we know n, we know the sample variance of size n, we know n, we know the next observation, and we know the sample mean for the sample size of n. So this is it. So we're adding that observation and recalculating the sample variance. And actually, to me, it's kind of surprising that we can do that. It's kind of a nice formula. And then as a reminder, the sample mean was this. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.